and now for something completely different. You know, as one of the few sort of scientific types here, you know, at the podium tonight, first of all, it's very exciting to be here, and it's certainly opened up my eyes. But you know, I think one of the missions of the university is, aside from study, one of the missions of the university is also to enrich the universe, or to enrich the world that we live in. And in an effort to appeal to the folks in the social sciences and the humanities, I decided to rope in Aristotle here, where he says in the Nicomachean Ethics that there are really several types of discipline that all are aimed at the general idea of the good. And you know, disciplines can be theoretical or they can be productive. And he argues that the theoretical disciplines are really more about thought and the acquisition of knowledge and the greater understanding of our world. But the practical disciplines are really about doing something good in the world and making something, presumably with that knowledge that you've acquired. And that, I think, really is the second half of what the university means. And I think that many of us fulfill that in our own ways. So one of my favorite jokes is about Isaac Newton, and I'll tell you why it's a joke in a second. So, so Isaac Newton, one of the great thinkers, you know, of our time, when he was a young man in his early 20s and was studying at Cambridge, the Great Plague came by in the mid-1660s, and he left and went to the country for a few years to escape the plague. And while he was out there, he invented the calculus and a few other useful things. But he came back to Cambridge after the plague and pretty much didn't tell anybody. He kind of kept it a secret until Leibniz several years later began to publish this, and then he said, oh, no, I did this first. So my joke about Newton is invent the calculus and tell no one. And that makes him similar to the Grinch. You know, I don't know if any of you watched the Grinch movie a few years back, but in one of the scenes, he's making a to-do list. And on his to-do list, he says, cure world hunger, tell no one. So we shouldn't be the Grinch, right? As we're figuring out how to cure world hunger, as we're figuring out the calculus, we should be telling people and making things in the world that will actually advance humanity. So my own personal journey actually looks moderately horrific. So I just kept going to school, you know, 4 years of college, you know, 2 years of medical school because I was in this MD PhD program. Then I scattled off and did graduate school. Then I did a postdoc for a while, then back to medical school, then an internship and a residency and a fellowship and then another postdoc. And, you know, I went for a long time there. And I piled up all this knowledge. And after about 20 years, I thought, well, there must be something we can do with this. You know, I've learned a lot about, I studied physics as an undergraduate. I studied some chemistry as a postdoc. I learned about medicine and physiology and all that good stuff. And so I opted to try to combine everything that I had learned and try to do something useful like make new tissues or make new organs. And as it turns out, knowing a little bit about many different branches of science turns out to be pretty useful if you're trying to construct a new tissue from scratch, from the ground up. And so that's what I started working on about 20 years ago. And this slide is overloaded with science kind of on purpose. And I don't want you guys to like read this in any detail or try to learn this, but what I'm trying to transmit is that as we were developing ideas about how to grow arteries, which is something that I started working on about 20 years ago, I actually had to put together many pieces of knowledge that were already in hand. Knowledge about how blood vessels grow and how they heal and what chemicals help them grow and heal and what mechanical forces they see and how the cells in them behave. And it was really a huge integration of many things that when it came together and when we sort of refined it and understood it better over time, over a number of years, resulted in this. So what I'm showing you here, not to gross out the audience, but what I'm showing you here is actually a photo of the first patient that got one of our engineered arteries implanted in his arm in order to aid dialysis. This was a patient with end-stage kidney failure who had to go and get his blood dialyzed 3 times a week. And this patient, who was in Poland actually, had one of our engineered blood vessels implanted under his skin so that he could undergo this dialysis procedure. And this is a photo below of a patient dialyzing through one of our blood vessels. So we've implanted now 80 patients with these blood vessels, and we're going to try to do more and extend our clinical trials. But I'm showing this mostly as a means of saying that by combining knowledge from all of these different areas, we were able to pull together something that actually, maybe helps somebody in the end. And, the similar type of thinking is involved in some of our work with engineered lungs. So I've been working on lung regeneration now for about 7 or 8 years. And it was really motivated for me by the observation of taking care of patients who are very ill, who have end-stage lung disease. And lungs, unlike blood vessels, really don't heal themselves. So once your lungs are badly injured, you're kind of done. And you either need a transplant or you expire. And so I'd been interested for years in trying to pull together enough knowledge and information and insights to try to run at the problem of whole lung regeneration, which is a hard problem. It's a big rompin' stompin' 20 or 30 or 40-year problem for sure, and we're about 8 years into it. But this is just showing you a diagram of some of the aspects of how lungs work. So certainly understanding how to rebuild a lung from scratch involves understanding what their structure is and how they work. And it also involves building devices like this one, which is a bioreactor in which we're able to culture large human-sized lungs in the lab. So I'm going to finish here just with sort of a little bit of encouragement in the sense that I think that we acquire so much knowledge here, as scientists, as students, as professors. And if we have optimism about what we know, and if we have optimism about problems that we can solve in the world, I think that there's a lot of good that we can do. But you have to combine that with realism, in the sense that, some people would tell me trying to grow a lung in a jar is probably not very realistic, and maybe they'll be right, I don't know. But, certainly when we started trying to grow arteries in jars 20 years ago, people told me that wasn't realistic either. So I think combining optimism with realism and having a good dose of both is actually pretty important. But certainly if you're going to do anything that's going to change the world, if you're going to treat your job like a calling, which I guess is what many of us do, then if you're going to change the world, it takes tenacity. That's for sure. Putting the problem down when it gets tough is never going to get you there. So I would urge you to learn, and I would urge you to actuate what you learn in the world, and I'd urge you to stick with it. Thank you very much.